Hello guys, today I am going to explain about rat maze problem. Rat in a maze. So what we have to find is we have to find a path where the rat can reach from source to destination. So this is our source and this is our destination. So the indexes will be 0 0 and here it will be n minus 1 and n minus 1. So what we have to do is we have to find a path where there will be multiple paths also, so we can return all those paths. So what we have to do is let us consider these whites are 1 and these are zeros. Let us consider that. So zeros are like blocks where we cannot move to this side, okay, and here also we cannot move because there is nothing beside these, and in these at this position we cannot go to the top also, right. Let's keep this in mind. Yeah, okay. So what is the bound here is, so if there is anything zero so we are not moving in that direction, so we are just uh, here only. Say for example we are here, so we have to find a path, means we have to move four directions, right, which is top, bottom, right and left. So we have to go through all these directions and left. So whenever we find 0 we are not considering that. So if we are at this, so we are here, so we will check and the top there is nothing and the left also there is nothing. Coming to right, here it is 0, so we don't consider this 0. And if we come down, so here it is 1, right, so we will come here. And along with this we are storing these to keep a track of our path, like from where we are coming we are taking another 2D array of same size of this, and we will update that one here, okay. So when we come here the same process will be done. So here also we have to check top, right, down and left. When we are here, when we call the top function again, what will happen here is, so here it is already 1, so we will go there. So again what will happen, from here also we will call again 4 direction. So what will happen, top, left and right there is nothing to go, and then again we will come here only. So what happens here is it will be looping continuously at these two positions only. So to avoid that we will take another condition also. So let's say this is our path. If our path is 1, it means our path of ij is 1, then we are not checking, okay, we will just return from there, okay. When we come here we found that this is in the path here it is 1, so we don't consider this also. So we go to right, we will go right, and from here also we will make 4 function calls. So we are solving this problem using recursion. This problem is based upon backtracking. Okay. So when we are at this position, right, so this is also 1, right, we will update our path with 1. So when we are here we will again make 4 function calls. Top here it is 0, so we don't consider that, and coming to right here it is also 0, so we don't consider this also. And when we go left, see it was already we are from there only, so we will check that. I'll give you the conditions first of all, so it will be easy for us. see if I less than 0, in the sense if we are, if let's say this is I, so this is I, so when we are here it is 0. When we call top function, what will change? I will change, I will become -1. There is nothing here, so at that point we will return, we will just return. And next, when I becomes out of our length, so then also we'll just return I greater than or equals to n. And next, same for j also. When we are let's say this is j, this is 0. So what's happened when we are at this, when we call the left function, what happens? J is 0 and j will become -1. So where there is nothing here, right? So in that case also we are just returning j less than 0. And when j becomes out of our length, then also we are just returning. And the one thing, this is our let's say this is our array mage. So then when we are not making any function calls, is whenever we find a maze of ij equals to 0, okay, maze of I and j equals to 0. And another thing is path of ij equals to 1. On what purpose we are checking this is not to make the continuous loops, like infinite loops. Path of ij equals to 1. Equals to 1. So whenever we find this condition, we are just returning. Otherwise what we are doing is we are just updating our path of ij with 1, because if it is not 0 means it is 1, right? So we are updating that with 1. Actually it became so messy here, so I will take that again. So we have to remember these conditions. Okay, whenever we reach at this position, we will just print our path. Okay, what I will do now is, okay, this is a mage. So whenever we are here, as I told you, so this is 1, right? The white spaces we are denoting with 1, and blacks are zeros. Blacks are nothing but these are the blocks. It means we cannot go in that directions. Okay, so in this case we are having only one path, that is so in this case we are having one path. Okay, let us track our path. This is 4 into 4, right? One more thing what we have to remember is this array should be like n into n, like n into n. Rows and columns should be same. This is my path. I'm just tracking my path here. Okay, so when we are at this position, we will make four calls, as I told you: top, left, right, and down. Only when this is 1, right? So this is 1. We can see that this maze of ij equals to 1. So whenever I found one, I'm just updating that into my path. Okay, because not to make recursive, not to make the calls looping. It's okay. When I am at this position, I'll check top. There is nothing. In the left also there is nothing. Coming to right, it was 0, so we cannot go in that direction. So whenever I come to bottom, so here also that is not 0, right? So I can go here. So whenever I came here, again I will make a 4 function calls. I'll go with top, right, left and bottom. Okay, when I make left top, I mean like top, I will check, I will see that whether it is 0 or not. It is not 0, and at the same time I have to check that whether this is not whether if it is 1, we will not go to there. So if this is 1, so we don't consider this one. Okay, whenever I am here, this was done, and there is nothing here. And coming to bottom also, it was a block, right? So it was block, so we cannot go in this direction. So I'll go here. So we can see that this is not 0, so this is 1, right? So I'll update my path with 1. So when I am here, I will again check top, right, bottom and left. Top, in top it was a block, in right also it was block. And when I go with left side, so here in that place we have updated with 1, so we don't go that side also. So when we call bottom, here it is 1, right? So what I'll do is I'll update this way in the path with 1, as it was not 0 and it is having a next path to go from that side. Okay, now I am in this position. So whenever I am here, the same, I'll call again top, left, right and bottom. Okay, now what happens here, when I go left it was a block, and right also it was block. And when I go top, I'll check that path, I mean like that particular index path, that it was updated with 1, so I don't go that side also. And when I coming to bottom, yeah, here it is not a block, means it is 1. So I will update this with 1 in the path. Okay, next, now I found 1 here, right? So now again what I will do is, it will again make 4 calls. So as we know that top, it was already updated with 1 in the path, so we don't consider this. And coming to left, yeah, that was okay. Yeah, we will go here, I mean like we will update this with 1. See, when we are here, we will again make 4 calls, right? So what happens here is, this left is 1. Okay, fine. Okay, we'll come here, and here also again we have to see 4 directions, right? Okay, and the top is 0, means which it is a block, so we cannot go on that side. And left there was nothing, and bottom also there was nothing, so we are stuck here. We cannot move here to any another side. So we will again come here in this one, and again we will go with the another call. So if we call bottom, there is nothing, so we will go with the right one. So we will go with the right one. Yeah, here it is not a block, it is 1, so we will consider this, and I will update that 1 in my path. Okay, when I am here, I'll again make 4 calls. So top it was a block, and left we already came from there. We know that if we are came from there, we have updated that 1. Coming to bottom, there was nothing, so what we have to do, we have to go with now right one. Okay, So we will go with the right one. As we know that this is not a 0, so we will update this path with 1. So when we are here, it means this is index n minus 1 and n minus 1, right? So when we are here means we can come to know that we have found at least one path, right? So I'll update this with 1. This is how we can get the paths. This is the one path for this. We can say that there will be multiple paths also. There might be not even at least one path. Let's say 3 by 3. I'll take 3 by 3. If it starts with 0, means we cannot have at least one path, right? And another thing is, what we have to remember, keep in mind is, the source and destination should be 1, then only we can get a path. Let's say this is 1, this is 0, and this is also 0. Let's say this is 1, this is 0, 0, 1. So let's say 1 and 1. Okay, it is 1. Okay, we can go any one of the down or this direction. Okay, let's say for example we will go this direction. When we are here, there was nothing, we cannot go up. In right also it was 0, and bottom also it was 0. So okay, this is not the path. Okay, we again come here, and this is 1, right? Now there was top nothing and left also nothing, we go bottom, it was 1. Yeah, okay, that's okay, fine. And coming to here also, we cannot go to right side as it was 0. And okay, we can't go left also. Okay, we will go down. Yeah, it was okay, we can come up to here. Okay, what happens when we come here? We cannot go this side. So what we have to do, we have to go this side, but we cannot go this side also because as it was 0, right? So in this case we don't have any path. We don't have any path. I hope you have understood like how we are checking this and why we took the another path array, right? Okay, let's say for example this is also 1. Okay, we can have a actually for now we are having this path. We may have another path like see, I have updated. Let's say suppose this is 1 I am taking to explain. So the another path might be like this and this is also another path, right? So we got one path. So whenever we found one path and we are making this to be 0, again we backtrack, we update this with 0. We got this from this, right? Okay, and this also will update with 0. We got this from this, so we update this 0. We got this from this, this, right? So okay, what happened, there is another one, right? So when we are here, we had made 4 calls, so we have chosen only one path at that time. So now we go with the another one. So we are having 1 here, so we go this side. Now we will check, as we have made this and this 0, when we are at this position, again the same as it is will be done. We'll be checking all the 4 sides. So we found this one here, so we will update now this 0 with 1. I'll update that with 1. So when I am here, so again I will check this 4 sides. Okay, when we go these 2 sides, as we know that when we come here we cannot find path, and coming to this side we are having one path, right? We can reach to our destination. So I'll update this 0 with 1. So Now we have found the another path, right? So initially it was like this, but now our path is this, right? Okay, I'll use another two. Okay, our new path is this. So likewise, how many paths are there? We can find that many paths. I hope the explanation was clear. And I'll just write code for this. So first what I will do is I'll take my image. As you know that we are dealing with 2D array. Yeah, this is array. Oh, what I will do first is I will write static void rat mage. What I'll pass here is I'll pass my mage. I'll just call this here. Okay, so in this what I am doing is initially I am passing the row and columns. First I'll take actually we want another 2D array to track our path, right? So I'll first declare that mage dot length. So I want a path of the same size of maze, right? So now we are going to solve our maze. So for that from here only I am passing the row and column. So solve maze. What are the things I am passing here is I am passing my maze array as well as row and column and the path also, because we have to update our path in that. Yeah, okay, now I'll go with the solve maze function. Static void solve maze. So what are the things I'm passing is int maze, int I, this is row, and int j, and my path, right? Okay, so what are the first conditions? The bounding conditions are, see, whenever our I like less than 0 or it is greater than equals to n, and also as well as j also, and if our maze of ij equals to 0 or our path of ij equals to 1, we are not going to do anything there, we are just returning from there. If I less than 0 or I greater than or equals to n, or j less than 0 or j greater than or equals to n, and next maze of ij equals to 1 means that is block, right? So we cannot go on that path. Maze of ij equals to 0 or path of ij equals to 1. If this is the case, we are just returning. If this is not the case means we can come to know that in that place that is 1, so we are updating our path with 1 now. So we are updating our path with 1. So this is a case first. And next, what is the case whenever we find n minus 1 and n minus 1 index, it means we have found one path, so we have to print that path. This is another case. If I equals to n minus 1 and j equals to n minus 1, I just have to print my path. So I'll take row 1 column, row equals to 0, row less than n, and row plus plus, and next for column. So I'm just printing my path. See, whenever we found we are at like last index, see, if we have multiple paths means we are just updating that with 0. Okay, updating that with in the path we are just updating that with 0, and again we are backtracking, right? So okay, this is for spacing. If we found one path and after that just giving the spaces. I'm making that ij to be 0, updating that to be 0, and just return true. Okay, we are done with this. Okay, this is for when to printing the path if we found any one of the path. Okay, next, what are the things we have to do is we have to make 4 function calls, right? So what are the things that will be changing? Okay, I will draw another one. Say, let's say this is I equals to 0 and j equals to 0. So we are at this position. If we want to get the top one, so what is the thing changing here is we are just decrementing the I. So for top, j will be same, okay, but what is the thing changing? I will be decremented. Okay, say for example for the right one, what is the thing? I will be same and j will be incremented by 1. Let's say we are at here, means the index is 0, right? If we want to come here, we have to increment this 0 by 1, right? So j plus 1 is for top, and for right I will be same and j will be incremented by 1. And next, coming to bottom, so what is the thing we are changing is let's suppose j will be same here, and what is the thing changes? If this is 0, it will be 1, right? So we have to increment our I by 1. And next for left, okay, for left, say we are at here. For left I will be same. What the thing will change is j will be decremented by 1. Okay, let's say we are here. If we want this index is 0 and 1. If we want this, the index here is 0 0, right? So which is the thing we have to change it? We have to change j. So j will be decremented by 1. So these are the things we are gonna do now. For top, again we will call this solve match. Initially the indexes are from 0 0, right? And now the indexes will be changed. This match will be same as it is. Top means what we are changing, we are decrementing I. J will be same path. This is for top. And for next for right, what is this thing we are doing? Right means, see, for right we are incrementing j by 1. Incrementing j by 1. We are done with the top and right. Next thing is bottom. Just going by clockwise. So bottom means what we are doing, we are just incrementing I by 1, right? The path will be same. This is for the bottom, and I'll go with left one. For the left one, j is decremented by 1. Okay, and next we're done with the 4 calls. See, I have already explained that we are updating the ij with zeros, because as we are backtracking, so after these calls I'll just update path of ij with 0 and I'll just return. Yeah, I hope everything what I said is and I have mentioned here. I'll just run this once. Just execute. Cannot find symbol. Yeah, okay. We have got 4 pots. I'll just copy all these. Okay, these are the paths, but what is the thing I have? My maze is okay. We'll see whether these 4 paths are correct or not. See, okay, we got Okay, so here it is like I'll take see here, here it is like 1 1 1 1 1, and this is one path. We'll see that we are having this 1 1 and these and these and these. Yeah, okay, this is correct. Yeah, okay, this is correct. And next coming to here, it was like this and this, right? Okay, we'll see. This right and bottom, and next add to destination. Yeah, okay, this is also correct. Next, coming to here, it might be like this and in this way. This is also one path, right? So okay, coming to this, okay, this and this. Yeah, this is also correct. And next is right, bottom and right. Yeah, this is also correct. This is how we can get all the parts. That's it, guys. I hope you have understood what I have explained. Thank you for watching.